Hello guys, welcome to my video on the x and y intercepts of an equation, and this will refer back to the first video of this section when I introduce coordinates on the x-axis and the y-axis. Now, as it says here, when analyzing graphs, we want to determine their most important features. Two key features are the x and y intercepts of a graph. These are the points on a graph where the graph intersects the x and y axes. Any point on the x-axis has a y-coordinate of 0. Therefore, the x-intercept is the point of a, 0, where the graph intersects the x-axis. Any point on the y-axis has an x-coordinate of 0. Therefore, the y-intercept is the point of 0, b, whereas the graph intersects the y-axis. Given an equation in x and y, define the x-intercepts. Substituting 0 for y in the equation and solving for x. Define the y-intercepts by substituting 0 in for x and solving the equation for y. Once again, referring back to that first video, remember, when the coordinate is on the x-axis, the y value is 0. So therefore, to find the x-intercept of an equation, replace the y value with 0, solve for x. When we have a coordinate or a point on the y-axis, the x is 0. Therefore, to find the y-intercept, substitute 0 in for x and solve for y. We're going to do that with these first equations down here. And then after that, I'm going to make a different video of an advanced feature. So we have these equations right here. Y equals to the absolute value of x minus 1, and then we have y equals x squared minus 4. Let's do the first one. Y equals to the absolute value of x minus 1. Let's find the x-intercept first. To find the x-intercept, we set y equal to 0. So instead of having y equals the absolute value of x minus 1, we're going to have 0 equals to the absolute value of x minus 1. And now we're going to solve for x. What I want to do here is I want to add 1 to both sides. So 1 equals to the absolute value of x. I'm going to write the equation as this. And by the way, I did pause the video and did forget where I left off at. So I apologize if it doesn't make sense what I'm talking about. I'm going to write the equation the other way. And now, just to remind you guys, the rules of absolute values. Suppose the absolute value of u equals to k. K is positive and real. Then u equals to k, or u equals to negative k. That was the rule of absolute value equations, going back to chapter 1, section 6, which I'm going to just bring us back to real quick so you guys can try to familiarize with that again. And that is one of the rules that is right here. If it equals to a positive number, we can set the inside equal to the positive version or the inside equal to the negative version and solve for x for each of those. So therefore, the absolute value of x equals to 1, we can write that as x equals to 1 or x equals to negative 1. And x is already solved for, so that is it. So these are my x-intercepts. My x-intercepts, in this case, are negative 1, positive 1. As coordinates, my x-intercepts will be negative 1, 0 and 1, 0. Because the x is either positive 1 or negative 1 when the y is 0. So these are different answers to listing out my x-intercepts. Now what we're going to do is we're going to find the y-intercept for the same equation. So now for the y-intercept, we're going to set x equal to 0. So instead of having y equals to the absolute value of x minus 1, we're going to have y equals to the absolute value of 0 minus 1. Solve for y. Now if we do that, the absolute value of 0 is just going to be 0. So y equals to 0 minus 1, and 0 minus 1 is just negative 1. So my y-intercept is just going to be negative 1, and as a coordinate, that's going to be the coordinate of 0, comma, negative 1. And those are both ways to write my y-intercept. Alright guys, that is it for finding the y-intercept to the absolute value equation. In the next video, we're going to find the x and y intercepts for the quadratic equation. I'll see you soon.